So here given slope of the line 45x plus 5y plus 3 is equal to 0 b 27 times r1 plus 9 times r2 upon 2, and then we need to find the limit of the integral where 3 to x 8t square upon 3r2x upon 2 minus r2 x square minus r1 x power 3 minus 3x dt. So let's find the slope of the line. Slope of the line 45x plus 5y plus 3 is equal to 0 b minus 45 upon 5, which is equal to negative 9. So which is given, therefore 27 times r1 plus 9 times r2 upon 2 is equal to 9. Make this as 1. And now consider limit x tends to 3 integral. You can see that the only the numerator part is with t and differentiation with integration with respect to t. So I can take integral 3 to x 8t square dt, and the denominator is complete is independent of t, so we can separate them. It's like 1 upon, so 3 r2x upon 2 minus r2x square minus r1 x power 3 minus 3x. And here when you substitute x is equal to 3, integral over the limit 3 to 3 will be 0 here, and denominator also if we substitute you will be getting 9 upon 2 r. Let us substitute here. When x is equal to 3, 3 times 9 r2 divided by 2 minus 9 r2 minus 27 r1 minus 9. So we can write here 9 r2 minus, which comes as minus 9 r2 divided by 2 minus 27 r1, which is minus 9, and from the first one equation we can say it is equal to plus 9. 9 minus 9 will become 0. So it is in the form of 0 by 0. So we can substitute here. We can apply the L'Hospital rule. LH rule we can apply. So differentiating, so we can write limit x tends to 3 d by dx of integral 3 to x 8t square dt divided by d by dx of 3 by 2 rx r2x minus r2x square minus r1 x power 3 minus 3x. And we know that integral f of x to g of x h of t dt differentiating is equal to h of g of x into g dash of x minus h of f of x into f dash of x. So by applying this concept, we can write here the numerator part limit x tends to 3 differentiating here 3 to x, so we can write 8t square, or we can write 8 times x square into differentiation of x is 1 minus 8 times of 3 square into differentiation of constant is 0 divided by differentiating the denominator, we'll have 3 by 2 times of r2 minus 2 times of r2x minus 3 r1 times x square minus 3, so that the numerator can be taken as limit x tends to 3 8x square divided by, and here we can simplify r2. Now let us not simplify. So here 3 by 2 r2 minus 2 times r2x minus 3 r1 x square minus 3. Now let us apply the limit here. x tends to 3. So we can write 8 into 3 square divided by 3 by 2 into R2 minus 2 into R2 into 3 minus 3 into R1 into x square, that is 3 square, minus 3, which is equal to, we can write 8 into 9 divided by, here 3 by 2 times R2 minus 6 times R2, that is 3 minus 12, that is minus 9 by 2 times R2 minus 27, 3 3 is a 9, 3 is a 27 times R1 minus 3. So from the first equation we have 9 upon 2 R2 plus 27 times R1 is equal to 9. So from that we can write 72 divided by, so this value is, so we can write here 9 upon 2 R2 minus 9 upon 2 R2 is minus 9, and again this is, sorry, it is minus 9. So we can write plus 9 here, minus 3. So 72 divided by 6. So 72 divided by 6 is 12. So 12 is the answer for this question. Let for any three distinct consecutive terms a comma b comma c of an AP, so given a, b, c are in arithmetic progression, then the lines ax plus by plus c be concurrent at the point P and q alpha beta be the point such that the system of equations has infinitely many solutions. Then find the length of the square of PQ. Since A, B, C are in arithmetic progression, so we can use the condition 2 times of B is equal to A plus C. Or we can also write it as A minus 2B plus C is equal to 0. So here when comparing with the general equation of a line, let us represent ax plus by plus c is equal to 0, the line passing through, these are set of lines which are concurrent at point P. Which means that for different values of B which satisfies the condition 2B is equal to A plus C, we can get different lines, and all those lines are concurrent at a point P. To find that one, let's comparing these two equations. A into 1 plus B times of minus 2 plus C is equal to 0. So comparing these two equations, we can say x is equal to 1, y is equal to minus 2. So it's very clearly all the set of lines are passing through one point, that is 1 comma minus 2. So we can conclude that point P is 1 comma minus 2. Now consider the system of equations which is having infinitely many solutions. Let's write in the matrix form 1 1 1 coefficients of the x y z in the first equation, and second equation 2 5 alpha and 1 2 3 into the variable matrix here x y z, which is equal to coefficients we can consider 6 beta and 4. For the given system of equations to have infinitely many solutions, the condition can be taken as determinant of the matrix A is equal to delta 1, where the first column can be replaced by the matrix B, which is equal to delta 2, which means second column of the matrix A replaced by the matrix B, and delta 3, which indicates the third column must be replaced by the matrix B, which are equals to 0. Its determinant values are zeros. So let's consider delta is equal to 0. So we get 1, 1, 1, 2, 5 alpha, 1, 2, 3, which is equal to 0. Let us substitute 1 times of, and here we can say that 5 into 3 minus 2 into alpha. So we write 15 minus 2 alpha, and again minus 1 times of, here plus minus plus, minus 1 times of, leaving this row and column. 2 3 the 6 minus alpha we can write, and again plus 1 times of, leaving this column and row we can write 2 to the 4 minus 5, which is equal to 0. And simplifying, 15 minus 2 alpha minus 6 plus alpha plus 4 minus 5 is negative 1. So which can be written as 15 minus 6 9, 9 minus 1 8, and minus 2 plus alpha is equal to 0. So we can say that alpha value is 8. And now let's consider delta 1. Since delta 1 is equal to 0, so we can take the first column must be replaced by 6 beta and 4, and the second and third column we have to write as it is 1, 5, 2, and 1. Alpha, in place of alpha I will write 8 and then 3, which is equal to 0. Let us simplify this. We'll get 6 times of 5 3 is a 15 minus 16, and minus 1 times of 3 into beta minus 4 into 8, and again plus 1 times of 2 beta minus 20 is equal to 0. So we can write 6 times of minus 1 minus 3 beta plus 32 plus 2 beta minus 20 is equal to 0. So we can write negative 6, negative beta, and plus 12 is equal to 0. 12 minus 6 is 6, minus beta is equal to 0. So we got the value of beta is 6. So we got the point alpha is 8 and beta is 6. So therefore point Q is 8 comma 6, and point P is 1 comma minus 2. So the points P 1 comma minus 2 and Q 8 comma 6. So PQ is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square. So we may consider the points here. This is x1, y1, x2 and y2. So which is equal to under root of x2 minus x1, that is 8 minus 1 whole square plus y2 minus y1, that is 6 minus of minus plus 2 whole square, which is equal to under root of 7 square plus 8 square, that is root of 7 sevens of 49 plus 64, that is 113, root 113. So we can say PQ is equal to root 113, or PQ square is equal to 113. So the value of PQ square can be taken as answer 113. Let the set C is equal to set of ordered pairs x comma y such that x square minus 2 power y is equal to 2023, where x and y are natural numbers. Then find the sum x plus y, where x comma y belongs to the set C. And here there is only one possibility, since we know that 45 square is 4 5 is 20 and 25, and 2 to the power 1 is 2. Subtracting, you will be getting 2023. So 45 power 2 minus 2 power 1 will be 2023. This is only one possible case we will be getting. So we can consider x is equal to 45 and y is 1. So we'll be getting the set C is equal to only 45 comma 1. This is only one element. So therefore the sum x plus y where the x and y, x plus y, x comma y belongs to the set C. So we can write only one ordered pair, that is 45 plus 1, which is 46. So 46 is the answer for this question. Let the area of the region x comma y, set of points x comma y such that 0 is less than or equals to x less than or equals to 3, 0 less than or equals to y less than or equals to minimum among the points x square plus 2 comma 2x plus 2. Be A. Then what is 12 times of A? So let us sketch the graph. 0 to 3. And y value is minimum of x square plus 2. X square plus 2 is a parabola. So when x is equal to 0, it is 2. So from the point, we can say that 0 comma 2. So this is the parabola. We'll be getting x square or y is equal to x square plus 2. And another one, y is equal to 2x plus 2. Let's see. It's a straight line. When x is equal to 0, it is 2. And you can see that when x is equal to 2, 2 to the 4 plus 2, 6. And here also when x is equal to 2, 4 plus 2, 6. We can see that the point, the line will intersect at this point. So this is how the straight line can be drawn. Or we can find by solving these two, x square plus 2 is equal to 2x plus 2. So we can write x square is equal to 2x, or x square minus 2x is equal to 0, or x times of x minus 2 is equal to 0, and x is equal to 0 and at x is equal to 2, these two will be intersecting. So when x is equal to 0, you're getting the point 0 comma 2, and when x is equal to 2, you're getting 2 comma 6. And now x lies between 0 to 3. You can say that from 0 to 3, this is the line. So the graph can be given as minimum of x square comma 2 and 2x plus 2, means from, we can say 0 to 2. The minimum is here parabola. So this is the graph we can shade. And again from 2 to 3. So straight line is the minimum. You can see that the graph is, the parabola is going beyond the straight line. So minimum is the straight line. We can say integral, or from 0 to 2, from 0 to 2, minimum is parabola, y is equal to x square plus 2, and from 2 to 3, minimum is the straight line, that is y is equal to 2x plus 2. So the required area, let us take A is equal to integral 0 to 2. We can say that the minimum, that is a parabola, x square plus 2 dx, and again from 2 to 3, we can consider the straight line, that is 2x plus 2 dx, which is equal to, simplifying, we'll get x power 3 divided by 3 plus 2x over the limits 0 to 2, and again now 2x, we can write 2x square upon 2 plus 2x over the limits again 0 to 2 to 3. So we can write 2 cube, that is 8 upon 3, plus 2 2s are 4, minus 0, and again here 3 square, that is 9, plus 2 3s are 6, and minus we can write 2 square 4, plus 2 2s are 4. So therefore A is equal to 8 by 3 plus 4, and plus we can write 9 plus 6 15, and minus 4 plus 4 is 8. So 8 upon 3, 15 plus 4, 19, 19 minus 8 is 11. So 11 3s are 33 plus 8, 41 upon 3. So the value of A is 41 upon 3, and we require 12 times of A, that is 12 into 41 by 3, which is equal to 4 times of 41. So we can say 4 into 41 is 164. So therefore the answer is 164. Let O be the origin and M and N be the points on the lines x minus 5 upon 4 is equal to y minus 4 upon 1 is equal to z minus 5 upon 3, and the line L2 x plus 8 upon 12, y plus 2 upon 5, and z plus 11 upon 9 respectively, such that Mn is the shortest distance between the given lines, then OM into ON is equal to. So here let us consider is equal to lambda, so that we can find some general point on the line. We can write x minus 5 upon 4 is equal to lambda, y minus 4 upon 1 is equal to lambda, and z minus 5 upon 3 is equal to lambda. So general point on the line L1, say M, we can take 4 lambda plus 5 and 1 lambda plus 4 and 3 into lambda plus 5. Similarly, if we can consider as a mu, some general point on L2, say N, is a point we can consider. So here x plus 8 upon 12 is equal to mu, y plus 2 upon 5 is equal to mu, z plus 11 upon 9 is equal to mu. So we can write the point as 12 times of mu minus 8, 5 times of mu minus 2, and 9 times of mu minus 11. So we got the 2 points here, M point and N point, and also the direction ratios of the first line. Direction ratios of line L1, say B is equal to, we can write 4 comma 1 comma 3, and direction ratios of second line L2, say B1 and B2 here. B2 is equal to 12, 5 and 9. So these are the direction ratios, and the direction ratios of the line MN, direction ratios of line joining MN, we can write as 12 mu minus, you can subtract these 2 points, 12 mu minus 8 minus 4 lambda plus 5, because the direction ratios of line joining 2 points is x2 minus x1, y2 minus y1, z2 minus z1. So we can write here as 12 mu minus 8 minus 4 lambda minus 5, or 5 mu minus 2 minus lambda minus 4, and 9 mu minus 11 minus 3 lambda minus 5, or we can also write 12 mu minus 4 lambda minus 8 minus 5 is minus 13, and 5 mu minus lambda and minus 6, and 9 mu minus 3 lambda minus 11 minus 5 is minus 16. Now since Mn is the shortest distance between the given lines, so let us consider the first line L1 with the direction ratios b1 vector and L2 with the direction ratios b2 vector means parallel to b2 and m and n are the points. Since to get the mn the shortest distance, so the line joining m and n must be along the b1 cross b2 vector or parallel to it. So let us find b1 cross b2. Since the direction ratios of b1 are 4 comma 1 comma 3, so we can consider the vector 4i plus j plus 3k. So we can write I, j, k, 4, 1 and 3, and b2 vector direction ratios are 12, 5, 9. So we can consider here 12i plus 5j plus 9k. Let us simplify I times of, so 9 into 1 minus 5 into 3, 9 minus 15 minus j times of 4 into 9 36 minus 12 into 3 36 plus k times of 4 into 5 20 minus 12, which is equal to 9 minus 15 is minus 6i, and this is 0j, and this is 8k. So we got the b1 cross b2 vector, and we have the direction ratios of mn. Direction ratios of mn vector is 4 lambda, sorry, 12 mu minus 4 lambda minus 13, 5 mu minus lambda minus 6, 9 mu minus 3 lambda minus 16. Now since b1 cross b2 and is parallel to mn, so we can write 12 mu minus 4 lambda minus 13 upon the direction ratio of this vector is minus 6. We can write here minus 6 is equal to, since they are proportional, next we can write 5 mu minus lambda minus 6 upon, and here we can say 0, which is equal to 9 mu minus 3 lambda minus 16 upon, and here we can consider 8. Let us solve these equations. By solving 1 and 2, we get minus 6 times of 5 mu minus lambda minus 6 is equal to 0, or we can write 5 mu minus lambda minus 6 is equal to 0, and from, so this is from 1 and 2, and this is from 1 and 3, we get, we can write here 12 mu minus 4 lambda minus 13 upon negative 6 is equal to 9 mu minus 3 lambda minus 16 upon 8. Simplifying, we get, so here let us cancel before cross multiplication, 2 3 times and 2 4 times. So we get here after cross multiplication 12 fours are 48 times mu minus 16 lambda minus 13 fours are 52 is equal to minus 27 times mu minus of minus plus 9 lambda plus 16 threes are 48, or simplifying 48 plus 27, that is 75 times mu minus 16 minus 9, that is 25 times lambda, and again minus 52 minus 48, which is minus 100, is equal to 0 by taking 25 common. So we'll get 3 mu minus lambda minus 4 is equal to 0. So we got another equation, 3 mu minus lambda minus 4 is equal to 0. Adding these two equations, we get 5 mu plus 3 mu is 8 mu, and minus lambda, sorry, subtract it. Let us subtract. By subtracting 5 mu minus 3 mu is 2 mu, minus lambda, minus or minus plus lambda gets cancelled. Minus 6 plus 4 is minus 2 is equal to 0. So we get mu is equal to 1. Substituting mu is equal to 1 in the equation 1. So we get 5 minus lambda minus 6 is equal to 0. Or we can write minus 1 minus lambda is equal to 0. Or lambda is equal to minus 1. So finally we got lambda is equal to minus 1 and mu is equal to 1. So the points can be taken. M is the point with the direction ratios 4 lambda. M is the general point we consider 4 lambda plus 5 comma lambda plus 4 comma 3 lambda plus 5. We can write the point M as 4 into minus 1 minus 4 plus 5 is 1, and lambda plus 4, that is minus 1 plus 4 is 3, and 3 lambda, that is minus 3 plus 5 is 2. And similarly the point N here, N is equal to 12 times mu minus 8 comma 5 times mu minus 2 comma minus 9 times mu minus 11, which is equal to n point. Mu value is 1, so 12 minus 8 is 4, and 5 minus 2 is 3, and 9 minus 11 is minus 2. So we got these points M and N. Now we need to find OM dot ON, means dot product of these two, which is the direction multiplication we can use. So we get our MOM vector, we can write it as I plus 3j plus 2k, and ON vector we can write 4i plus 3j minus 2k, so that OM dot ON is nothing but dot product. So 1 into 4 plus 3 into 3 plus 2 into minus 2 minus 4, so which is equal to 9. So we can say that OM dot ON is equal to 9. So 9 is the answer. If integral pi upon 6 to pi upon 3 root of 1 minus sine 2x dx is equal to alpha plus beta root 2 plus gamma root 3, where alpha, beta, gamma are rational numbers, then find 3 times alpha plus 4 times beta minus gamma. So let us simplify. Integral pi by 6 to pi by 3 under root of 1 minus sine 2x dx, which can be written as, and we know that, let us simplify here, 1 minus sine 2x is equal to, we can write it as sine square x plus cos square x minus 2 sin x cos x. So that is sin x minus cos x whole square, or cos x minus sin x whole square we can write. So therefore under root of 1 minus sin 2x we can write, so pi by 6 to pi by 3 under root of 1 minus sin 2x we can write it as under root of sin x minus cos x whole square dx. We know that under root of x square is mod x, so we can write mod sin x minus cos x from pi by 6 to pi by 3 dx. And we know that the graph from 0 to here, pi by 6 is 30 degrees and pi by 3 is 60 degrees. So let us take here pi by 6, and here it is pi by 3, and then again pi by 2. We can see the graph of sine from 0 to 90 degrees, it's increasing, and again say this is 30 degrees, you can write this is 60 degrees and 90 degrees, and 45 degrees will be here in between. And the graph of cos, it decreases from 1 to 0. So we can say that this is the graph at x is equal to 45 degrees. Sin x and cos x will intersect. That's 1 by root 2. And clearly we can see that from 0 to pi by 4, from 0 to 45 degrees, that is pi by 4, cos graph is greater than sine graph. So I can split here pi by 6. So since our concept is from pi by 6 to, we need to think about from pi by 6 to pi by 3 only. So I can write integral pi by 6 to pi by 4, and here cos is greater than, so we can write cos x minus sin x dx, and again from pi by 4 to pi by 3, sine graph is greater than cos x, so we can write sin x minus cos x dx. Now let's integrate integral of pi by 6 to pi by 4 cos x dx minus integral pi by 6 to pi by 4 sin x dx, and again from integral pi by 4 to pi by 3 sin x dx minus integral pi by 4 to pi by 3 cos x dx, which is equal to integration of cos x is minus sin x, and over the limits pi by 6 to pi by 4 minus integration of sin x is, sorry, integration of cos x is plus sin x, and integration of sin x is minus cos x, and over the limits pi by 6 to pi by 4, and again integration of sin x is minus cos x over the limits pi by 4 to pi by 3, and again minus integration of cos x is sin x over the limits pi by 4 to pi by 3, which is equal to sin pi by 4 is 1 by root 2 minus upper limit minus lower limit sin 30 degrees is 1 by 2 minus of minus plus, so cos pi by, or let me give the minus here, so minus of minus cos pi by 4, that is minus 1 by root 2, minus of minus plus cos pi by 6, that is root 3 by 2, and again here plus of minus cos pi by 3, that is cos 60 degrees is 1 by 2, and again here minus of minus plus 1 by root 2 minus, and here sin pi by 3 is root 3 by 2 minus sin pi by 4 is 1 by root 2. So on simplifying, we can get 1 upon root 2 minus 1 upon 2 plus 1 upon root 2 minus root 3 by 2, and again minus 1 by 2 plus 1 by root 2 minus root 3 by 2 and plus 1 by root 2. So here 1 upon root 2, 1, 2, 3, 4. So we can write 4 divided by root 2, and minus 1 by 2 minus 1 by 2. So you're getting minus 1, and again minus root 3 by 2 minus root 3 by 2. So we'll be getting minus root 3. So we can write 4 upon root 2 as multiplying and dividing with root 2. So we'll get 4 root 2 divided by 2, that is 2 root 2. So 2 root 2 minus 1 minus root 3. So when it coming to the given part, alpha plus beta root 2 plus gamma root 3. So we can express this as minus 1 plus 2 times of root 2 plus of minus 1 times root 3. So when comparing with alpha plus beta root 2 plus gamma root 3, so we can say alpha value is negative 1, beta value is 2, and gamma value is minus 1. Therefore, the sum 3 times of alpha plus 4 times of beta minus gamma is equal to minus 3 plus 8 minus of minus 1. So 5 plus 1, 6 is the answer. So we can go with an answer 6. Let alpha comma beta be the roots of the equation x square minus root 6x plus 3 is equal to 0, such that imaginary of alpha is greater than imaginary part of beta. Let a comma be the integers not divisible by 3, then and n is a natural number such that alpha power 99 by beta plus alpha power 98 is equal to 3 power n times of a plus ib. Then n times n plus a plus b is equal to. So let's take the roots. So we can get x is equal to minus of minus root 6. We have the formula minus b, x is equal to minus b plus or minus under root of b square minus 4ac divided by 2a. For quadratic equation, ax square plus bx plus c is equal to 0 for a is not equals to 0. So we can get under root of b square, that is minus root 6 whole square is 6 minus 4 into 3 is 12 divided by 2 into 1 2. So x is equal to root 6, and again 6 minus 12 is minus 6. So we can write root 6 plus root 6i divided by 2. Or if I take root 6 common, root 6 upon 2 common, 1 plus or minus I. Root 6 upon 2 we can write root 2 into root 3 divided by 2 can be written as root 2 into root 2. So we can write root 3 times 1 upon root 2 plus or minus 1 upon root 2 I. So 1 upon root 2 plus 1 upon root 2 I, since e power I theta is equal to cos theta plus I sin theta, 1 by root 2 we can write it as root 3 times of cos pi by 4 plus or minus I times of sin pi by 4. So you are getting two values. So root 3 times of, according to this concept, we can write e power I theta, and e power minus I theta is equal to cos theta minus I sin theta. So one can be taken as e to the power of I pi by 4, and another one we can consider root 3 times e power I minus I pi by 4. So one can be considered as alpha, and another one we can take it as beta. So alpha and beta are here, root 3 times e power I pi by 4, and beta is root 3 times e power minus I pi by 4. Now consider alpha power 99 upon beta plus alpha power 98, which is equal to, by taking alpha power 98 common, alpha upon beta plus 1, that is alpha power 98 times alpha plus beta upon beta. And we know that from the quadratic equation x square minus root 6x plus 3 is equal to 0 when alpha and beta are the roots. So sum of the roots is equal to root 6 minus b by a. And also we got alpha is equal to root 3 e to the power of I pi by 4, and beta is equal to root 3 times of e to the power minus I pi by 4. Let us substitute here. So we get e to the power root 3 times e to the power I pi by 4 whole power 98 into root 6, we can write it as root 2 into root 3 divided by beta value is, we can write root 3 times e to the power minus I pi by 4. So here root 3 gets cancelled, and root 3 power 98 we can write 3 to the power of 49, 3 power 49 into e to the power of I 98 pi by 4, and again plus I pi by 4 from the denominator into root 2. Or we can add 3 power 49 into root 2 into e to the power of I 99 times of pi by 4. So which can be written as e to the power of I 99 power 4, we can write cos 99 pi by 4 plus I sin 99 pi by 4, which is equal to 3 power 49 into root 2, and cos 99 pi by 4 99 pi by 4 we can write it as 24 times of pi plus 3 pi by 4. So 24 means 12 complete rotations plus 3 by 4. So we can also write this as cos 3 pi by 4, and again I sine. Here also 24 means 12 complete rotations plus 3 pi by 4. So sine 3 pi by 4, which is equal to 3 power 49 times root 2 into cos 3 pi by 4 value is minus 1 by root 2 and plus I into 1 by root 2. So we can write 3 to the power 49 into root 2 into 1 upon root 2 of minus 1 plus I. So we may cancel here root 2 and root 2. So which can be taken as 3 power 49 into minus 1 plus I. Now comparing with the other side. So 3 to the power of n into a plus ib. So when comparing with 3 to the power of n into a plus ib, we can write it as n is equal to 49 and a is equal to minus 1, b is equal to 1. So we need to find n plus a plus b, which is equal to 49 minus 1 plus 1. So we can give the answer as 49. So 49 is the answer for this question. Let P alpha comma beta be a point on the parabola y square is equal to 4x, and it also lies on the chord of the parabola x square is equal to 8y. Let us consider the parabola x square is equal to 8y, whose vertex is origin 0 comma 0, the standard form, and this can be written as x square is equal to 4 into 2 into y, and let us consider AB is the chord. AB is the chord whose midpoint is given, say 1 comma 5 by 4, and this chord is also passing through the which point which is alpha comma beta. So let us find the equation of the chord. Equation of chord when its midpoint is given, when its midpoint say x1 y1 is given, so we have t is equal to s1. That is, for the equation x square is equal to 8y, we can replace x as xx1, and 8y can be taken as 4 times of y plus y1. So 2y we can write it as y plus y1. So the tangent equation can be taken as x1 minus 4 times of y plus y1 and is equal to s1. S1 means substituting the point x1 y1 in the equation. So we'll have x1 square minus 8 times of y1. And simplifying this, since the midpoint is given 1 comma 5 by 4, substitute x into 1 minus 4 times of y plus 5 by 4 is equal to 1 square minus 8 into 5 by 4. So x minus 4y minus 4 5s are, that is 5 comes, 20 divided by 5, which is equal to 1 minus 10, that is minus 9. Or we can write x minus 4y, 9 minus 4, that is plus 4, is equal to 0, which is the equation of chord. And it is mentioned that point alpha comma beta lies on the chord. So we can write alpha minus 4 beta plus 4 is equal to 0, and also this point lies on the parabola y square is equal to 4x. So we can say that beta square is equal to 4 alpha. So beta square is equal to 4 alpha is one equation, and alpha minus 4 beta plus 1 is equal to another equation. So solving these both equations, solving two equations, from the first equation let us substitute beta is equal to, or alpha is equal to beta square upon 4 and substitute alpha value in the second equation, that is alpha minus 4 beta plus 4 is equal to 0. So we will get beta square upon 4 minus 4 beta plus 4 is equal to 0, or beta square minus 16 beta plus 16 is equal to 0. So beta is equal to 16 plus or minus under root of beta b square, that is 256 minus 64 divided by 2. So we can write beta is equal to 16 plus or minus 256 minus 64. So we can write 192. So square root of 192 divided by 2. So we can mention, so 8 plus or minus, and 192 we can write it as 8 root 3. So we can write 4 root 3. So beta value is 8 plus or minus 4 root 3. And then alpha is equal to, we can say betas, or we have alpha minus, from this equation alpha is equal to 4 beta minus 4, that is 4 times of 8 plus or minus 4 root 3 minus 4, that is 32 plus or minus 16 root 3 minus 4, that is 28 plus or minus 16 root 3. So we can consider the value of alpha is 28 plus 16 root 3 and another one 28 minus 16 root 3. So let us assume 28. Now we need to consider alpha minus 28, which is equal to alpha minus 28 is equal to plus or minus 16 root 3 also we can write, and beta minus 8 from here plus or minus 4 root 3. Since we required alpha minus 28 into beta minus 8, which is equal to plus or minus 16 root 3 into plus or minus 4 root 3. So we can write 16 fours are 64 into 3, which is equal to 192. So let us consider 192 is the value. Alpha minus 28 into beta minus 8 is 192. 192 is the answer we can give. Find the remainder when 64 to the power 32 to the power 32 is divided by 9. So let us consider 32 to the power of 32 is equal to, say, some t, some integer, some big integer. So we can write this as 64 to the power t, which is equal to 8 square whole power t, that is 8 to the power of 2t. So 8 power 2t we can write 9 minus 1 whole power 2t. Let us expand by using binomial theorem. 9 minus 1 to the power of 2t is equal to, so we can write 2t c naught 9 to the power of 2t, and again we will get alternate minus 2t c1 9 to the power of 2t minus 1 plus 2t c2 9 to the power of 2t minus 2, and so on, and here we'll get minus. Last but second term let me consider. We'll get minus 2tc 2t minus 1, it's an odd number so we'll get minus here, 9 to the power of 1, and again the last term will be positive 2t c 2t 9 to the power of 0 into 1. So here we can say clearly, except the last term, all the numbers are multiple of a 9. So 9 power 2t, it's a very big number, so 9 is definitely can be taken common. So 9 into, we can say it's a multiple of 9. It's a multiple of 9 plus 2t c 2t value is like NCN is equal to 1. So we can say this is 1. So we can write this as something like 9 into some integer k is an integer 9k plus 1. So 64 to the power of 32 to the power of 32 is a number can be written as 9 into something plus 1. So which implies that when this 64 power 32 power 32 is divided by 9, the remainder is equal to 1. Dividend is equal to divisor into quotient plus 1. 1 is the remainder. So we can say answer is 1. Let f of x is equal to root of limit r tends to x 2r square of f of r whole square minus f of x into f of r upon r square minus x square minus r power 3 into e power f of r upon r be differentiable in minus infinity to 0 and 0 to infinity, means except at x is equal to 0, and f of 1 is given 1 and f of a is equal to 0. We need to find the value of e into a such that f of a is equal to 0. So given f of x, so if we can square f square of x is equal to, we can write limit r tends to x 2r square of, here f of r whole square we can take f of r common, and then we can write f of r minus f of x divided by r square minus x square minus r power 3 into e power f of r divided by r. So which is equal to limit r tends to x 2r square of f of r into f of r minus f of x divided by, we can write here r plus x into r minus x minus r power 3 into e power f of r divided by r. Now let's separate. Limit r tends to x 2r square into f of r divided by r plus x into limit x tends to r tends to x f of r minus f of x divided by r minus x minus, we can apply again limit here, limit r tends to x r power 3 into f of r divided by r. So here limit r tends to x f of r minus f of x divided by r minus x can be considered as f dash of x. So we can consider it to be, this is f dash of x. So we can write, f square of x is equal to limit r tends to x 2 r square of f of r, we can write 2 x square into f of x divided by x plus x, that is 2x into f dash of x minus, and here we can write x power 3 into e to the power f of x upon x. So f square of x is equal to, so x into f of x into f dash of x, that is dy by dx minus x power 3 into e to the power f of x upon x, and f of x is equal to y, so f dash of x is equal to dy by dx. So let us write f square of x is y square is equal to x into y into dy by dx minus x power 3 into e to the power y by x. So we can write, dividing with y square, 1 is equal to x upon y into dy by dx minus x power 3 divided by y square into e to the power y upon x. Now let us substitute or put y upon x is equal to some v, so that y is equal to x into v. Differentiating, dy by dx is equal to v into dx by dx is 1 plus x into dv by dx. So we can write 1 is equal to x upon y as 1 upon v into dy by dx as v plus x into dv by dx minus x power 3 by, that is x into 1 by v square into e to the power v. Or simplifying, we can write 1 is equal to 1 plus x upon v into dy by dx minus x by v square into e to the power v. Or you can write v square is equal to, or we can v square is equal, or we can simplify and write x upon v dy by dx is equal to x upon v square e to the power v, because 1 and 1 gets cancelled, and here v also can remove, so x also we can cancel, so we can rewrite this as v upon ev dv is equal to dx. So after simplifying, we got the equation variable separable form v upon e power v dv is equal to dx. So we can write here, integrating on both the sides, v into e to the power minus v dv is equal to dx. So integrating on both the sides. So by using the by parts here, according to the Eilert rule, exponential function will come later. So first v into integrating of e to the power minus v dv minus integral of differentiation of v is 1 into integral of e to the power of minus v dv whole dv, which is equal to x plus some constant c. So here v into e to the power of minus v divided by minus 1. So here minus integral of e to the power minus v divided by minus 1 dv, which is equal to x plus c, or we can also write minus v upon e power v minus minus of minus plus, again integral we can write e to the power minus v divided by minus 1 is equal to x plus c. So further we can write it as minus v upon e power v plus or minus 1 upon e to the power v is equal to x plus c, or minus of v plus 1 divided by e power v is equal to x plus c, or we can write e power v into x plus c is equal to minus of v plus 1, or v plus 1 plus e to the power of v of x plus c is equal to 0 is the equation. And now it is given f of 1 is equal to 1. So at x is equal to 1, or let me replace what is y, v is equal to, let us replace, since we have taken y upon x is equal to v, so we can write y upon x plus 1 plus e to the power of y upon x into x plus c is equal to 0. Now at x is equal to 1, y is equal to 1, so we can write 1 upon 1 plus 1 plus e to the power of 1 upon 1 times 1 plus c is equal to 0, or we can write 2 plus e to the power 1 into 1 plus c is equal to 0, or e power 1 of 1 plus c is equal to minus 2, or we can write 1 plus c is equal to 1 plus c is equal to minus 2 upon e, or c is equal to minus 1 minus 2 upon e. So let us substitute in the equation. So we have y upon x plus 1 plus e to the power y upon x plus x plus c, that is minus 1 minus 2 upon e is equal to 0. Now again at x is equal to At x is equal to a, y is equal to 0. So let us substitute 0 upon a plus 1 plus 0 upon a into a minus 1 minus 2 upon e is equal to 0. So we can add 1 plus e power 0 is 1 times a minus 1 minus 2 upon e is equal to 0. So we can add 1 plus a minus 1 minus 2 upon e is equal to 0, or we can simplify here a is equal to 2 upon e, or ae is equal to 2. So the value of ae is 2. So 2 is the answer.